Hello friends, in today's question, consider a body of mass 1 kg at rest at origin at time t is equal to 0, a force alpha ti plus beta j is applied on the body where alpha is 1 Newton per second and beta is 1 Newton. The torque acting on the body about the origin at time t is equal to 1 second is tau. Which of the following statement is true? So this can be a single correct or multi-correct option. So it is given to us that at time t is equal to 0, the mass of 1 kg is at rest at the origin. So you can say at t is equal to 0, body is at rest at the origin. So therefore we can say that velocity will be equal to 0 and r will be also equal to 0. Now it is given that the applied force F is equal to alpha ti plus beta j, and value of alpha is 1 Newton per second and that of beta is equal to 1. So substituting the value of alpha and beta, we get that the force will be equal to ti and j. So this is the basic equation for the force where the value of alpha is 1 and beta is also equal to 1. Now we can use the basic formula that force is equal to mass into acceleration. So you can say, but force is equal to mass into acceleration, which can be written as mass and acceleration is derivative of the velocity. So this is dv by dt. From here, mass is our 1 kg. So we get this as dv by dt as m is equal to 1 kg. So we can write this particular equation now that dv is equal to f times dt, substituting value of f, that is ti plus j. So this becomes ti plus j times dt. So now we are going to integrate this equation for time 0 to t and velocity for 0 to v. So integrating, we get integration 0 to v, dv is equal to integration 0 to t, and this becomes ti plus j. So from here we get left side will be equal to v and right side we get t square by 2 plus, sorry, there will be I also, and this will be equal to t times j. So this is the equation for the velocity, and velocity we know is dr by dt. We can say that velocity is equal to derivative of r divided by t, so which will be equal to t square by 2 times I plus t j. Once again, we can write this equation as dr is equal to t square by 2I plus tj times dt. Now once again, integrating the equation from 0 to r and 0 to t, integrating, we get 0 to r, dr is equal to 0 to t, and this is our t square by 2 times I plus t j and dt. So left side becomes our r, and this is equal to t cube by 6 plus, and this becomes t square by 2. So this is the value of the position vector r. Now we know that value of position vector r, equation of position vector r, and the equation of velocity as well as the equation of the force. So we are going to find out that at t is equal to 1 second, our position vector r will be equal to 1 by 6 I plus 1 by 2j, and velocity vector will be equal to 1 by 2I plus j, and we have the force, applied force, will be equal to I plus j. So these are the values at time t is equal to 1 second. Now we are supposed to find out the torque at t is equal to 1 second. So we know that the equation of the torque is equal to r cross f, substituting value of r cross f, r and f respectively. So 1 by 6 I plus 1 by 2j cross f is I cross j, I plus j, and we get that the torque will be equal to 1 by 6 minus 1 by 2, and this will be k vector, which comes equal to minus 1 by 3 and k unit vector. And we can find out here magnitude of torque. So magnitude of torque will be equal to 1 by 3, and this is at t is equal to 1 second. Therefore, we can say that, let me write the unit, that is Newton meter. So option number A is true. Okay, so you can say A is true. Now let us find out for other conditions also. And next is we have to find out that B is what will be the direction of the torque, in which direction. So we just found out that the torque is equal to is 1 by 3, and this will be minus k unit vector. You can see, but so from here we can say that the direction of the torque is toward minus k unit vector, whereas in the option it is given that it is towards plus k unit vector. Therefore, the option B is false. B is false. Next, we had to find out the velocity of the body at t is equal to 1 second is given by v is equal to 1 by 2 I plus 2j meter per second, and we already know the equation for the velocity, and we know that velocity, we already found out this part, that velocity is equal to 1 by 2I plus j. Let me check. I think I made a mistake. I think velocity and the velocity we found out, you can see, but velocity is 1 by 2I plus j, and this can be modified as taking 1 by 2 as common, so this becomes I plus 2j. Okay, this is, you can say, according to this equation, because v is 1 by 2 I plus 2j. So if you modify it, so we get this equation. Therefore we can say option C is also true. C is true. And we have to find out the last part, that is D, that the magnitude of displacement of the body at time t is equal to 1 second is 1 by 6 meter. So we find out that displacement vector, we can say, but R is our, this is our R vector, 1 by 6I plus 1 by 2j, so 1 by 6I plus 1 by 2j, and we need to find out its magnitude. So its magnitude will be equal to 1 by 6 whole square plus 1 by 2 whole square and its square root. So its magnitude is equal to, this will be coming as 1 by 36 plus 1 by 4 square root 36, we have LCM, and this becomes 1 plus 9 and its square root, so this will be equal to square root of 10 divided by 6 meters. But the option given to us is that it is 1 by 6 meter. So you can say option D is false. Option D is false. Okay, so here we check option D, here we check option C, and here we check option B. Okay, and this is our for option A, this part. So we can say only A and C are true. That's our final conclusion. So we can say option A and C are true, whereas option B and D are false. So we can say our option A is true, option B is false, option C is also true, whereas option D is false. So this completes the question. Thank you.